Hello everybody. Uh, I reviewed the first and second part of homework 1 3 days back. Now let us review the final two parts and we can move on from homework 1 to the next assignment. The last two assignments are a bit difficult ones. You are seeing my VMware. If you run the RSpec, all my test cases are executed now. You see all 42 examples are executed with 0 failures. I already submitted my homework assignments. There also the test cases executed successfully without any issues. Now let us see the code for the last two assignments. The third assignment is a game where the player chooses one of the strategies, either rock, paper or scissors. There were some rules given in the homework sheet about who wins the game based on their strategy. If you see the program, there are two methods. One will determine the winner between two players, and another is a tournament in which we pass in a array where each element of the array can be a group of players, and we decide a winner from each group. If the strategy is anything other than the rock, scissors and paper, we need to throw an exception. So the line at 4 is used for that. We have extended the standard error. It is called no such strategy error. For the winner of the two players, we are first checking whether the strategy is between the or among the rock, scissors and the paper. If it is not, then we are throwing an error saying that the strategy must be one of R, P and S. Once we move on from that, we have the three rules which determine whether out of the strategies picked up by player 1 and 2, who will be the winner. If both players pick up the same strategy, the first player wins. So that is the first OR condition. The second OR condition is for specifying if player 1 chooses rock and player 2 chooses scissors, as out of these two, as rock can break scissors, player 1 wins. Similarly, I have coded the conditions in which player 1 wins, and if any of the conditions are not met, player 2 wins. This is the easy part. The second one is a bit tricky one. Here we are receiving a tournament in which a tournament is an array. Each element can be either a player or set of players. If it is a set of players or a sub tournament, we need to recursively again check for the winners in the event set. So now we are using recursion here, as a hint is also provided to use recursion as part of the assignment question. The terminating condition is we are choosing whether if the array passed is having only 4 elements. The force significance is that if there are two players each player can have their name and the strategy. So for two players, there will be four elements. So we will recursively call this function till we reach only two players. And once the two players are reached, we can find a winner and return it. If the array we have is containing a group of players, then we are selecting the tournament winner out of the first group and the second group. So on we do a recursive way. Finally, we reach a state where only there are two players. So we will find a winner, and then the trace back continues till we find a final winner. And that final winner is returned. Okay, it took some time for figuring this out, but finally I could get it. Now, let us see the fourth example. This is also a bit tricky one. We are asked to write a XSR like attribute XSR, which provides both the read and write facilities. But the requirement is to save the old values that are assigned to the attribute, and once the get method is accessed, we should be in a position to, or once the method with the underscore history or attribute with underscore history is accessed, we should be in a position to return all the previous values. Here also the skeleton was provided in the exercise. The equal method is being overwritten or overwritten from the class object. The method has one argument as value. So once that equals method is called, that is, we are assigning a value to the attribute, this equals method is applicable to all attributes. So because of this class eval, we are in a position to do it. We are using a or equals operator. What it does is, if it is already having a value assigned to it, it will not disturb it. Otherwise, it will assign a empty array. This is defined on the line 8. Now, once the history attribute is identified, they are pushing the old value to it at line number 9 and assigning a new value to the attribute. And once the reader is accessed, we are just returning the attribute name underscore history attribute. That will give all the values of it. So if it is accessed by underscore history, we are returning the field we have created, which contains the old values also. That is defined as a instance method, as you can see, at the rate and is being defined, and hash is used to access the field. This finishes our assignment. Thank you very much.